We actually, in the last video, we did talk about the standard normal distribution. We said it fits or satisfies a few criteria, one of them. What's the shape of it? Has if you graph it, has a bell shape. What else? It has an average equal to what? 0. And the other one has a standard deviation equals to 1. So a bell shape again will look something like this, the graph. Standard deviation of 1, so your average is right here. Average is 0. Few things about this graph. This actually goes all the way to infinity on both ends. It never really touches the x-axis, like asymptotes for the math people. The x-axis here, or this line, is the asymptote, which you approach that line, but you never touch it. It's evenly distributed. That means half of it on the right side, half it on the left side. I can add that to that list too. Spread evenly. And the other one we said, the area, if you calculate the entire area under that, the area should be what? 1. Well, if it's spread evenly, that means to the left of this dotted line, the area is what? 0.5, and to the right of this is 0.5. It's 0.5 on the left side, 0.5 on the right side. The entire area is 1. And we say symmetric, evenly or symmetric. This becomes really important, symmetric. Because in a few minutes, we're going to show you how to read the value using these charts, this table. The only problem with that table, it reads to the left of the value, not to the right of it, just to the left. So what about if I need the value to the right of that?
Could you do 1 minus the value?
Well, I could. If I want this area, let's say this is 3 here. This is 0 here. If I want the area to the right of that, my table doesn't help me. It gives me to the left. I can do that since the whole thing is 1 minus that number. Or, Scott, since it's symmetric, I can look for the -3. And I'll look to the left of -3. Because symmetric graph, the area to the left of this is the same size the area to the right of that. So that's why I wrote the word symmetric here, for that reason. But I could do 1 minus that number, yes. We call this the density curve, actually. And now, how do we read them? We say the area is 1, good. What about if I want to find the area? So I'm going to learn how to read that table there. I said, can you tell me what is the area to the left of negative 1.32? First, the number I'm writing down the bottom is called the z value, or the z-score. That's what that is. Z equals negative 1.32. How do you find the z-score?
Isn't that the standard deviations away?
Well, it's 1.32 standard deviation to the left, yes. But how do we calculate what that number is? How do we know if your score is 1 standard deviation to the left or to the right? Well, we can calculate that by taking x minus mu over sigma. That's how you calculate what the z-score. If you're dealing with the sample, it's x minus x bar over s. So for example, let's say I gave a test. The test has an average. Everyone took the test. That means nobody was out that day. The test has an average. That's a population, so everyone took it, of 82. The stat class not that hard, so the average was high. And let's say the standard deviation for that test was a 6. And Trent, you scored on this test, so I'm going to pick on you here. You scored, I don't know, 74 on it. What is Trent's z-score? So z-score for Trent is going to be what? His score, which is the 74, minus mu, the average. What was the average? 82 divided by what? 6. 74 minus 82 is what? Negative 0.8, negative 8, yeah. Negative 8 over 6 is negative 1.33. The standard deviation is always rounded to 2 decimal places, always. So Trent is actually negative 1.33 to the left, 1.33 standard deviation to the left of the average, below the average. Scott, you scored on the test. You scored 82. What is the z-value for Scott?
0.
It's going to be his 80 score, which is 82 minus the average, which is 82, divided by 6. He is 0. He's 0 standard deviation above or below the average. That means he's right on the average. Dan, you scored 92 on this test. Dan's standard deviation is going to be what? 92 minus 82 divided by 6. (92 minus 82 is 10. 10 divided by 6 is what? 1.67. Dan is 1.67 standard deviation above the average. So that's how we calculate the z-value. So now let's go back to Trent. Trent wants to know how many people scored below his score. He's a minus 1.33. What percent of the class have a score below Trent? So let's go back to Trent here. His score was negative 1.33. And he's curious, says, okay, am I the lowest score in the class? How many people scored below me on this test? Well, how do we find what that value is? The area to the left of that.
You go down the z's to negative 1.3 and then go over to
Well,
3.
first thing first, guys, we need to know which one of these tables to use. See that?
Negative.
Yep, we have positive and negative z-scores. So since Trent's score is actually negative, I have to look at this table. So the handout I gave you has front and back. One is positive, one is negative. So find the negative side. And this side here carries the first decimal place. So you find the negative 1.3 on this side. This entire row is negative 1.3. This whole row. The first value, notice on the top, the second digit is 0, so this is negative 1.30. This is negative 1.31. This is negative 1.32. This is negative 1.33. So the area to the left of that is 0.0918. So Dan doesn't look good here for you. I mean Trent, sorry. Doesn't look good for you. Why? What percent of the class scored below your class here? Only 9%. Only 9% of the class scored below your score. Scott here, his z-score was 50. I mean, 0. I already gave you the answer. Well, I don't even have to look at the table. We know the whole area is 1. So what's half of that? 0.5, which is what? 50%. So he's right in the middle there. That's the class. Now Dan's score was what? 1.67. Let's see what percent of the students scored below his score. Now, I got to use the positive z-score, not the negative. So I'll find the positive z-score, and I will look for 1.67. This 1.6, and I'll keep going till I find the 7. Right here. See that 7? That's your second digit. 1.67. 0.9525. $95.25. So Dan actually in the top 5% of the class. There's 95% of the class scored below his score. Yes, Scott?
I'm sorry, what are the arrows going into it?
Well, if you look at these numbers, notice it says this number here is halfway between these numbers. I know you can't read them in the bottom here, but this is halfway, so this one is right there. It says if you have a value of 2.575, we're going to use 0.9950. I'll come back for that later. And this number, that's for the positive z-score. The other number, if you're trying to read that, this is halfway between 1.64 and 1.65. So it's 1.645. And the value for that, we're going to use 0.94 or 9500. It's halfway between these numbers.
Are those numbers common?
Yes.
Okay.
Well, that's not just common, it just happens to be the 9.5 is halfway between them. You'll see in a minute why these were circled. When we get to the confidence interval, we start talking about 95% confidence interval, we need to know what these numbers are. Now, I told you the first day when we talked about standard deviation, I threw some numbers here. Anyone remember what is within one standard deviation? What percent within one standard deviation?
65?
We got 65, 67, 68. 68% of the people within one standard deviation. We said 95% of the people within what? 2 standard deviation. And 99.7% within what? 3 standard deviation. And where did the math come from? Well, let's look at it. Can you tell me what is the area between 1 and minus 1? What is the area between these two? This is within one standard deviation. Notice between minus 1 and 1. So this is the probability of z value greater than or equal to negative 1, less than or equal to 1. Well, if I look at the 1.0 on my positive z-score, the 1.0 gives me an answer of what? 0.8413. Can you see that? 0.8413. But if I do that, I'm actually getting this area. I'm getting, it's going to get messy, so I'll do it. This is the one here. If I look at the area to the left of 1, I'm getting all of this. So now I got to look at the minus 1. Yes. I got to look at the minus 1, and the minus 1 gives me that number. And if I subtract them, do I get what's in between them? So let me look. So this is z equals to 1. Let's look at z equals minus 1, and let's subtract them after. So let me find what is the area to the left of negative 1. 0.1587. Everyone see that? Negative 1.00. And let's subtract them.
You also do 1 minus 1.587 times 2.
And subtract from 1 you could, because symmetric.
Yes.
Yes. 0.8413 minus 0.1587. And that's 0.6826, which means what? 68.26% of the people land within 1 standard deviation. Now let's try 2 standard deviations, just to see if these numbers are really right. I'll do one more. What about 2 standard deviation? What's the probability that z score between negative 2 and 2? So that's 2 standard deviation. Let's see if you have 95%. So we're going to look at the 2, and we're going to look at the negative 2 and subtract the 2 answers. So z equals 2.00. The area, according to the positive z-score, 2.00. See it? 0.9772. Now we look at z equals negative 2.00. That's the negative z-score. 0.0228. Subtract the 2 numbers. Is that a 95%? .9544. So it's 95.44% of the values land within 2 standard deviation, and we can prove the 3 standard deviation too.
All it says is the 2 sides are in balance. They're in balance. When you're solving an equation in algebra, all you're trying to do is make the 2 sides equal. So for instance, if you have something like this.
So the table that we're looking at here always gives you the area to the left. So you have to be careful. Sometimes we go, can you tell me the area to the right? So I might say to you a different example. Can you tell me what is the area to the right of 1.96? Again, I have 2 options. Scott gave me one option early, and I gave you that option. 1.96. And I'm looking to the right. What Scott said, look at the area to the left. You know the whole thing is 1. So it's 1 minus the area to the left of 1.96. Because you know it's 1. So it's 1 minus, and what is the area to the left of 1.96? I go to my table, 1.96. Is it 9750? 9750. And that'll give me what? 0.0250. That's one way of doing it. Or, I say, you know what? I said the graph is symmetric. why not just look the area to the left of negative 1.96? Since you have a symmetric graph, it should be the same answer. If I find the negative 1.96 here, and I look at the area to the left of that, it should be the same as to the right of 1.96. So instead of subtraction, all that, I go negative z-score, negative 1.96. Here's the 1.9 all the way to 6. Right there, 0.0250. Is that the same answer? Yep, you can do it both ways. What about working it backward? Okay. I forgot what the average height of a male in the USA is. It 5 feet, maybe 9 inches, the average height? So let's assume, I used to know these numbers, 5 feet, 5 times 12 is 60 plus, what's it, 9 inches? So the average height of a male is 69 inches. And the standard deviation is 2.6. I'm making that up, inches. Now, I'm designing doors for this building, and I want to make sure that at least 95% of the people fit through that door based on these numbers. So what height can I use here to make sure that 95% of the people will be able to walk through that door without bending their head?
2 cents.
Well, maybe.
There's always a goal in mind for the game.
Okay, because 95 actually, it's 2 from here and 2 from here, right?
You're gonna do 2 standard deviations from the positive z-score?
Maybe. Well, the way I'm going to do them, I know this area is 0.95. We're going to work the problem backward. So what z value here? Find the z value. That has an area to the left equals 0.9500. And this is where your question comes up here, Scott. Well, it's not one of the match. Yeah, it is. So now I have to look inside the chart. Not on the outside, inside the chart. What is the closest number to 0.9500? Well, here's the problem. There's 9495 and 9505. See it? So I can't use this one because that's 5 less. If I use this, why not that one? They're exactly the same distance. So to make sure we are fair to both of them, we opted to go with an asterisk there and say, you know, if you need to use 0.9500, use 1.645. It's halfway between the two numbers. So that's why that error there.
Gotcha.
So the z value will have to be 1.645.
Say, for instance, in our class, say a class B
So I'm working the problem backward now. Now, if I know the z value, can I find what the height should be? Well, z is equal to what? X minus mu over sigma.
So in 1 week,
1.645 equals x, which is the height I'm looking for it, minus the average height, which is what? 69, divided by what? Sigma, which is 2.6. So I'll multiply these two, 2.6 times 1.645, 4.277 equals x minus 69. And to solve for x, I gotta add 69 to both sides. It should be about 73.3 inches. So based on the numbers I gave you, based on this, the 69 inches standard deviation of 2.6, if I make the height of that door 73.5, I know 95% of the people will be able to walk through that door. I'm only discriminating, or I'm only hurting 5% of the people.
find out
They're going to bend their head to walk through that door.
Isn't that the same type of thing that they do for like airplane seats?
Seat, the width is, you measure from bone to bone. That's the width of your human body, bone to bone, on your hips there. And they try to make sure the seats are big enough to satisfy 95% of the passenger. Now, granted, there are some people get on the plane, I watch the show, 600 pounds and still losing weight, you know. That person's not going to be able to fit in a normal seat. And they want to sue the airline and say, it's not fair. Well, you know, buy 2 tickets. That's what they tell you, actually. Yep. And to make it even worse, and I've seen that, try to fit through the bathroom if they have to use the bathroom. They can't. You know? Let's take another example. We'll use MIT, Harvard, Yale, Princeton. MIT, that's engineering school. So since we science, engineering, computer science, you know, MIT. MIT is only going to accept the top 7% of their applicants. Top 7%. That was the acceptance rate for Harvard and Yale last year. The top 7%. Here's the other bad story of that. When they say top 7%, an average person with SAT score 12, 1300 is not going to be applying to Harvard and Yale and Princeton, MIT. They know they have no chance in hell of getting in. So the ones who apply to these schools usually have SAT scores probably about 2200. Now the SAT score, I don't know when's the last time you took your SAT score. It used to be out of 1600, but they add the writing portion to it. Now it's out of 2400. So the maximum score on SAT score is 24. So the average for those people applying to MIT, average SAT score for students applying to MIT is 2200. And the standard deviation is 75. Or let's say 80. I don't know. Most of these people are going to be around that score, like 2300, most of them. So the standard deviation is going to be really small for those students. And MIT says we're only going to take top 7% of people applying to us. We're going to look the other way. I don't care what you did for other stuff. If you were the captain of the football team, if you played in a band, you did any of this stuff, I don't care. I'm only going to go by SAT scores. And you're sitting home going, I scored 2,300 on this test. Do I have a chance of getting accepted into MIT? Well, let's see. MIT is only going to accept the top 7%. So I need to know what score here. What score will allow me? If you're higher than that, yes, you will go to MIT. If you're below that score, no, you will not be going to MIT. So if they're accepting 7% of the students, that means the area to the left, that's the rejection. What percent of the students being rejected from MIT? 93% of the students will be rejected. That's 0.9300. So let's find the Z value that has an area equals 0.9300 to the left of it. You're saying Z equals 1.48. So again, the way we do that, for those people not sure, since this number is more than 0.5, I need to be looking at the positive Z-score. You look inside the table for 0.9300. 9300. I'm getting closer, closer. I got these numbers. See them? 9306, 9292. Which one's closer? Is it the 6? The 6 is closer. So it's 1.48. So now, what score do we need to get to MIT? Z equals x minus mu over sigma. 1.48 equals x, which is unknown, I'm looking for it, minus 2,200 divided by 80. You're not going with that score. Let's see. So 80 times 1.48, it's 118.4 equals x minus 2,200. We add 2,200 to both sides. It's 2318.4. Since there is no 0.4 score, so the minimum score you're going to need to get to MIT is what? 19. That's your minimum score. You have to have an SAT score of higher than 2319 to get to MIT. I know I just looked at them again because I'm always looking at these numbers. I know Harvard, Yale, and MIT are about 7%. Okay, Mr. McDonald?
You make that up?
Yep. Usually when you start doing problems, the book will tell you, or the problem will tell you, whatever the story is. Could be the story is lost luggage at airport has normal distribution. It always state has normal distribution, and it will tell you what the mean is and what the standard deviation is. The height of a woman is normally distributed. With the mean is this, the standard deviation. I'll give you actually a true example. I've seen this. I saw this in Dear Abby. This guy was actually in the Navy, came home, brief visit to his wife, and left. And his wife gave birth way after the 9 months period. And the question was, is it possible for somebody to give birth that far? What is the probability of that happening? So let's make a problem along that line. Woman pregnancy is normally distributed. Anyone, I know you guys, hopefully, any of you have kids? Good, you're too young to have them. The average pregnancy is what? 9 months, in case you don't know that. So 9 times 30 days, an average number of days per month. What's 9 times there? 270 days. So normally distribute with the mean. And standard deviation of 15. This is actually true. Pregnancy is normally distributed with the average, with the mean of 270, standard deviation of 15. That's 15 days, that means 2 weeks. Most of people deliver their kids 2 weeks within the due date, either 2 weeks before, 2 weeks after. Unless you have, if it's way before that premature baby, is way after, the doctors will never let you go beyond that. They'll induce you. They'll give you this chemical that will put you into labor quickly, and you have that baby that time. The story goes, this actually person gave birth way after the visit, more than 270 days. I think it was 315 days. So the question, what is the probability that a pregnancy will last more than, let's say, 300 days? I know for that story it was more than 300, but I can't remember exactly, it was 315 or whatever the number is. So I'd say more than 300 days. Notice this is actually, we're dealing with probability now. We're going to take the problem, the way we solve these, we take the problem and look at it, not in terms of the z-scores, in terms of the real scores that we have. It says pregnancy is normal distribution. It looks like this. And this is your average, right smack in the middle. The standard deviation, I'm going to write it down under that of what? 15. And this sailor came home and his wife gave birth after 300 days. Where's the 300? Right here. And this person's questioning if that baby is his or not. Because is it possible for somebody to give birth after 300 days? So what percent of the people give birth after? So we're looking for that area. We need to take this problem and change it to x. To z. Change to z values, z scores. So what is the z value here has to be?
2.
Z equals x minus mu over sigma. X is what? 300 minus mu, which is what? 270 divided by 15. The z value for this happens to be 2. You always want to use 2 decimal places, 2.00.
being a division problem, they were multiplying over dividing.
Now,
Well, that's because we're multiplying.
what is the probability that the pregnancy will last more than 300 days?
Well, you can use negative z score of 2.
So I can use 1 minus that number or use symmetry. Remember, the area to the right of 2.0 is the same size to the left of negative 2.0. So look at the negative z-score. Negative 2.0, which is what? 0.0228. So now, that says, you know what? This is not rare. It happens 228 times out of 10,000 pregnancies.
Isn't that rare because it's like less than 5%?
This one?
Yeah.
Yeah, it is percent, but I mean, when you look at it, like you're saying, it could be my kid. It's not impossible. You know? Still happens. It's not often it happens, but it still happens 0.0228, 228 times out of 10,000.
Very likely.
Well, in this case, not bad. I think that story, it was Dear Abby, I think it was like 315, 345 days. And the chance was really, really small.
I just checked the longest that there was 375 days.
Ooh.
That's wild.
Was that a person or an elephant?
They give birth to that kid,
Yeah.
they just have their birthday party already prepared.
Well, the reason why the numbers could be off, because when you find out you're pregnant, you go to the doctor, they estimate when you think you get pregnant. And sometimes they could be off because nobody knows when you got pregnant. You know? The person even having the kids don't know because they've, especially if they've been trying for a month and a half, you don't know you're pregnant till about 2-3 months later. Oh, I'm pregnant. And it could be last week, last month, it could be this one. They can pinpoint it within a few weeks, actually. They're not that far, but they could be way off. But again, this is not a rare case like impossible to happen. We're saying it does happen 228 times divided by 10,000, or every 10,000 pregnancy, or it happens almost twice every 100 pregnancy. So you can't say, oh, that's not my kid. You can go on Maury and go, he is your child, you know. Whatever that show Maury does. You are the father, you know. So that's how we do these problems. Quick one, another one. I can make a computer one. Let's say, for example, the average life, I'll make it a two-part. The average life of a computer. When I say the average life, it means the machine. That doesn't mean the machine died. It becomes like obsolete, useless. You know, if you bought a computer 4 years ago, probably worth nothing now. It's a piece of junk because the technology changes so often. So let's say it's 36. How about 40 months? And after, then they start breaking down with a standard deviation of 5 months. Do you ever buy a computer? The first thing they try to sell you is what? Protection. Now, how good the protection plan?
For a couple of years.
Couple of years. Okay, so
2 years right now.
2 years?
I used to sell them.
Yep. Let's say let's see what percent of them. Find the probability I'm assuming as normal distribution. I forgot to write that. Assume normally distributed there. Find the probability that a computer will die or break down in less than 24 months. In less than 24 months, on the first 24 months. Again, you graph that before we get to the z value. The average life, we said normal distribution, assuming computer life is normally distributed with the average, that's mu equals 40. Standard deviation is what? 5. And now they're going to sell you a warranty for the first 24 months. This is the 24. So if your machine breaks any time before that date, they'll fix it or replace it for you. So what is the z value for that 24? Z equals what? 24 minus 40 divided by 5. 24 minus, is that 16? Is it 3.20? Let's see what percent of the computers now will come back for repair or replacement for Z. That's negative here, yep. Negative 3.20. So let's find the negative 3.2. Negative 3.2. 0.0007. 0.07%. Do you remember what was used to sell them, right? What was how much they charge people for?
For a 2-year accidental protection plan on a PC's above $300 is $200.
200 bucks?
Yeah.
Let's say 200 bucks. What that tells you here,
Anything above 300,
Yeah.
anything below 300 is $100.
that means 7 out of 10,000 will break. So watch why they make money on that. They want to sell you that policy. 7 out of 10,000 they will break down. So if they sell 10,000 of them at, you said 200 bucks?
Yeah, 200.
So they will collect from the people what? 2 million bucks? Holy moly.
Yeah, it's because they're not making any money on the PCs.
Yep, that's where their money is, yeah.
That's where all the money is. I've had, because we also sell them on everything else,
Yeah.
I find it very stupid. We had someone buy a $5 protection plan on a $10 USB cable.
Oh my goodness.
Yeah, it's ridiculous.
So now, if they have to replace 7 of them, what is the machine, $1,000?
Yeah.
We expect 7 of them to die when you sell 10,000. They're going to collect $2 million to replace 7 computers. Even if the machine was a super duper machine of 10,000, 7 times 10, 70,000, collecting $2 million for it.
Take it all day.
Yep. Now, and sometimes they work the problem backward. They're trying to get you, like I said, listen, let's make the warranty really more incentive to them. So what they do, they go, can you tell me what month? Let's increase that. I don't want to spend a lot of money, but I don't want to repair more than 10%. So can you tell me what month will have a value of 10% here? I only want to be able to replace 10% of them. Can you tell me what that value is? Because now if they say we're going to give you a policy for 3 years, they're going to charge you more money.
3-year protection plan is like, I think, $210.
Is it 210? Because you're going to see there's not much of a difference between them.
Negative 3.1.
10% here. So you want that number to be 10%. So the area to the left equals 0010. 0.1, I'm sorry, no, that's 0.100, right? Not 00. That's 0.100. So look inside the table. 0.100, 0.1, where's the 0.1? What was it? 0.1, negative you mean, right? Negative 0.1, 1.28 you said? Point. 127. It looks like right here, huh? Is that 0.1? 09.111. We're looking for 0.100. Yep.
1.28.
Negative 1 point, yep, it is negative 1.28. So the z value has to be negative 1.28. Now let's calculate that will cover how many months? Negative 1.28 equals x minus, what was the average we said for computers? 40 months? Standard deviation of what? 5? Five times 1.28, 6.4 equals x minus 40. X equals what? 46.4.
It should be negative 6.4.
Negative, oh yeah, that's a negative, so that would be a little bit less, 33.6. You're almost getting 3 years, right? So you can go with the warranty of 3 years, you're only still getting 10% of the computers coming back. I still take that, because people will pay you now $210 or $220 to have, that warranty there. You got 3-year warranty instead of 2 years for $20 more. Okay, I'll take it. And again, we're talking about 10%. So if you sell, what is 10%? 1 out of 10? So if you sell 10 warranties at each one, what was it? Let's say now $230. You're going to collect from them how much money? $2,300, and you're only going to fix one of them. And probably that computer is like $400, $500. Not as much profit as the other one. The other one's way more profit because we didn't have to fix even 1% of them.